Sometimes in you said write it down.
Write down and give it to me. Don't write it down.
You said write down what?
Pull up your notes from last class and write down the rotation.
From last class?
See if you can relate what you have been doing. It's not that simple.
Wait, what you mean by
Look at the symbol. What symbol is that? What angle is that? That's a different, that's side.
that's not too, right?
No, that's not side.
Oh, that's 5. Oh, see, I'm.
You want us to write 5 on the paper?
Of course.
So there.
So what's
Last
going on?
class.
So that is that. Whatever that this thing is, look at that angle. What angle is there?
That's really like 1.5.
Huh?
I the same thing she is. Oh, I just didn't change. I just didn't change this.
Write down how do you denote it? Notation for that.
Oh, the R.
R equal to on the other side. Always write a notation on the other side.
I think it's like 200. And then 1 is.
Equal. 1 comma p equal to.
Oh.
Equal. In between.
So.
Got it, Jalen?
So, you all.
So which one is this one, right? I need this.
Oh, which is all separate. Actually.
Got it? One. Just write your name. But make sure you write this equal to. That is important. Now what you're going to see here is, if you're in reality, you're not going to move only about one axis. You're just going to randomly move. How do you express? Now, for example, if you're if I ask you to move, and I want to follow your coordinate systems, how much you move. You're not going to move like this. If I ask you to move to that point, how are you going to move?
You moving along
A straight line. Or you're going to move in space if you're able to move in space in a straight line. But what we do is we track XYZ there and we track XYZ there. Similarly, any rotation will happen about A axis. You understand here I, J, K are fundamental axis, right? But the axis of rotation could be any axis. You understand what I'm saying? So for example, you take this. What is the x rotation of this? Assuming this is x, y, and z. What is the x rotation? This thing, right? What is the y rotation? This one? Right?
Oh, z.
Sorry. What's the y rotation? This one actually. Right? And the z rotation is this one. Now, rotation generally doesn't happen like that, right? It will just happen. This is just a random rotation. Okay? But it is still about one axis. That axis is not necessarily one of the fundamental axes. It could be an axis in between. Okay? Now, what we do is, just to understand our basics, or conceptually it's difficult to visualize all the rotations at once. So what we do is, this is going to get a little bit complex, so just pay attention. Look at what is the first initial rotation of this.
What?
The initial rotation. Initial.
Goes around Z.
Huh?
Goes around Z.
The initial rotation, not the initial rotation, but the initial orientation. What is the initial orientation? So if you see, the initial orientation is this x. Better? The initial rotation is, or initial orientation is x, y, and z. Got it? The final rotation is x prime, y prime, z prime. Look, Michael, keep it here.
No, this is my problem.
So if you look at what the initial rotation is x, y, or initial orientation is x, y, z. And the final orientation is x prime, y prime, z prime. Okay, so x prime, y prime, z prime is this x, y, and z. Okay, now if I draw this, this is the initial rotation. This is x, y, and z. And the final rotation is x prime, y prime, and z prime. Okay. So here, if I were to demonstrate, this is the initial orientation. Look at this this thing. This is the initial orientation. Okay. And this is the final orientation. But we don't understand 3D rotation all at once. So what we are going to do is, we are going to get there one fundamental rotation at a time. What is a fundamental rotation? Rotation about the fundamental axis, about one of the fundamental axes. Okay. Now if you see the first rotation, can you identify what the first rotation is about? It's actually indicated there. It is about z-axis. Why so? Where is the first rotation? So what is the first rotation? If I were to write the notation, what is this first R? Let's say R3. R1 is 3 and alpha? Yes, you're right. The first rotation is about the z-axis. Does everybody see that? Okay. So what happens when you rotate about z-axis? Only it is x and y change. The second rotation is about? Tell me the second rotation. X-axis?
Yeah.
What is the angle?
Beta.
So your second rotation is about R2. What is this? 1?
Yeah, beta.
Huh?
I was just weird. I was
You see the
wondering.
numbers?
Yeah.
There's no 2.
You can also, there are a lot of indications here. Okay. One is that 1, 2, 3 is clearly mentioned. Plus, if you see, initially Z and Z1 align. Z and Z1 are the same.
Oh, yeah.
Right?
Excellent.
So that is the first rotation. And then X1, X2 are the same. That means it's about
The same.
X1 axis. And then Y2, then again Z2 and Z prime are the same. So the third rotation is again about Z axis. Okay. And what is the angle? Gamma. Okay. Now what we do is to express this complete rotation. The complete rotation R we'll just say prime y prime z prime x y z equal to you see this? This is the formula for complete rotation. You see this? This is what we are saying is to go from XYZ frame to X prime, Y prime, Z prime frame. We have used 3 rotations about 3, 1, 3 axis. Okay. Now the rotation sequence. What is the rotation sequence? If I say ask you to the rotation sequence is 1. Yeah, correct. So it's 3, 1, 3, and the angles are alpha, beta, gamma. But the
Why is it 3, 1, 2?
Huh?
Because it's Z and X. And
Oh, yeah.
Z, X, Z. Okay. Multiplication sequence is the opposite. Keep that in mind.
Oh, that's what's it called?
The multiplication sequence. This is a rotation sequence. This is the multiplication. If you see the multiplication sequence, alpha, beta, gamma. You see that? This is very, very important. You cannot switch this. If you switch this, you will get a different answer. Matrix, these are all matrices.
Wait, why do you have alpha first?
Huh?
Why do you have gamma?
I'm
Why you have gamma first?
That's
You
what I'm
said
saying.
we multiply x back.
The multiplication sequence is reversed.
No.
So that's what. Pay attention. Be alert and pay attention. This is going to be a big part of your exam. Exam 2. Okay. So this is the multiplication sequence, right? Now if I tell you. So what is the rotation sequence?
You said what?
Rotation sequence?
What you mean with it? 3, 3, 1. Oh.
3, 1, 3. And that is alpha, beta, gamma.
But the
What is the multiplication
multiplication
sequence?
is gamma,
Reverse.
beta, alpha.
It's 3, 1, 3, but gamma, beta.
Why you got R3
Should you
on one of them? Why you have R3 on
put
one
one
of
three
them?
on the other two?
I mean, it's still in the same order.
No, I'm just saying why you got 3 on the first R.
R3, R2, R1.
No, the first R next to it.
Multiplication.
The multiplication.
You wrote R3 and then put E.
So one of them, you don't need one.
R3, gamma, R1.
No, you can't. You put R subscript 3,
On the
3
first.
gamma.
So
You don't need that.
yeah, best.
The reason I had that was I wanted to make it clear that this is R3, third rotation, second rotation, first rotation. So here also it is third, second, first. The rotation sequence is 1, 2, 3, but the multiplication sequence is 3, 2, 1.
You don't need this.
Now, the amazing thing about this is, what you should really appreciate here is, you remember these angles, cap omega, I, small omega.
Yes.
What are these angles? These are the orbital parameters, right? You have, these are called Euler angles, okay? And the reason they are called Euler angles is, let's say you are in this K. This is X, I.
So tired.
And then you have J. And this is ECI frame, okay? What is ECI frame? You remember ECI frame? ECI frame is Earth-centered inertial. This what direction is this?
That's the in the direction of the north.
North pole or the axis of rotation. Okay? This is the north direction. What is this? The Aries constellation. Okay? Now if you execute this 313 rotation on this one by angle omega, cap omega, I, small omega, you will end up in PQW frame.
And the what?
In the PQW frame. What is PQW frame? Yes, so if you have the orbital frame, yes. So if you have this R3 omega plus R, this does not mean plus, but you know, I'll use this R1 I and R3 omega, you'll end up in P, Q, and this is Done. You understand? It's difficult to understand. I'll show you a figure. We have discussed this in the past.
Oh, I have a question. So what days are we going by for the final schedule?
Final schedule.
Yeah, what day are you going by? Like the original time, which was 11:14?
They'll mention that in the listing. We don't have a choice.
I know I have it. I'm saying,
So
what
just
day are you going by? Because we have like the original price day,
the
10 o'clock on Monday, Wednesday, Friday.
That's when we used to have class.
we'll probably have to go with whatever we have now, because there might be something for the 9 to 10. That exam might be.
They don't have an 8 o'clock schedule for.
Let's discuss that. Just give me a second.
It would be, because it's usually
Again, look at this. If you, let's say you're in the XY, as I mentioned, let's say you're in the ECI frame. You can identify the ECI frame here, right? Now do this rotation first. Tell me where you'll end up in. What will your x-axis collide with?
That would be, if we move it, like,
If you move it, if you do this rotation, just the first rotation,
that keeps us.
the x-axis will align with the line of nodes, right? X-axis will align with line of nodes.
Say if he's talking like if we use like these, but we exchange it with cap omega I and
So you have this as your this thing, okay? Or let me put this like this. This is your x-axis and this is your y-axis. The rotation is about z-axis. Now what is this axis? If you do a z rotation, what is this line?
the virgin region.
Let me.
Oh, wait, oh, that was the X.
That was the x, yeah. So let's say this is
I didn't
x.
listen to the
So if you do a rotation, what will this align with? If you do a this by cap omega, what will be the new line of nodes, right? This is the cap omega. This will not, nothing will happen to this. It will not align with anything. The y-axis will not align with anything. Okay?
Why won't it be the parity direction?
That is not omega.
Because it's small and.
That is not omega. Okay? That it doesn't have any significance. So just leave it here. It aligns with this
Yeah.
Okay.
Line
line of nodes, right? Now do another one rotation. Where will the one rotation be about now? About the line of nodes, right? What will happen by the next is one rotation about by angle I. Z will become
H.
H. So this is your new. This is your new Z. Okay? Right? Now when you rotate this by what angle?
The line of omega. So
By angle small omega, what will this align with?
Y.
Check. It's there. It's right there.
It goes to perigee direction.
It will align with the perigee direction.
Oh, when they go
That
all
is
the way
omega.
to- Oh yeah.
It will go like this. So this will become
The perigee.
the perigee direction. This will become the new P. Got it? And then simply that the y of that will is simply you complete that the right-handed rule. So you see why this is now you can make sense this P Q. This Q is this H selection. Okay. This P is
The perigee.
the perigee, and this is just I'm sorry. This W is this H.
Wait.
Because he rotated it, like he oriented it around the original,
Okay.
when we rotated the first time.
So now, see here, look at it. Look at this. This is what I'm drawing on both.
Okay.
Okay. This is what I'm drawing. This is what I'm drawing on board all the time. When I draw here the orbit, the P is. This is the P axis. Okay. And where is the H axis? How is the H? H is always coming out. You get it? Okay. So this is W or H to it. And this is the Q direction. Does this make sense?
So if that's a two-dimensional.
Guys, pay attention here, okay? Yes. So this is a two-dimensional drawing, yes. This is a three-dimensional representation. Does it make sense? We have to pay attention because this will be on your exam. Okay?
Is that supposed to be the case for like any time we do this? Like,
Because it will be different for 2, 1, 3 than 2, 7.
yeah, because like you said it's gonna change the ECI to a.
Right, so you can go from, that we'll cover that, I'll come to that. But you can go from ECI to PQW using any sequence 1, 2, 3, 2, 3, 1, 3, 2, 1. What's going to change is the angle. The angle will change. If it is 3, 1, 3, the angle will always be this cap omega I small omega. It's the right ascension of ascending node, the inclination and the argument of perigee. If it's 3, 1, 3. Okay. If it is 1, 2, 3, this will be simply
1, 2, 3.
1 alpha. You can take any angle. Now it becomes insignificant. This doesn't have a name. This alpha, beta, gamma don't have a name. But you can go from this rotation to that rotation using any sequence.
So you're saying that if it's 3, 1, 3, then that's when you see.
Yes. So these are orbital elements.
Mixed dimensional.
Hmm?
What were you asking? If it's 2, 1, 3, you use Euler angles. Not
Use Euler angles or you use these orbital elements, the orientation elements. Okay? Cap omega, I, small omega. Questions? Yes? Nick?
My question is,
Oh.
so are all the angles are those like set values or are those like the angles that just come?
It depends on what orbit you're talking about. Every orbit will have these. So what is the, if you're in a circular orbit, if you're in an equatorial orbit, sorry, what is your I? I will be, inclination will be 0. Got it? Because this K and H will align. So this angle will be 0 because they have to be 0. What is the inclination if it's a polar orbit? What's a polar orbit? Huh? It will
Orbital.
orbit the poles. If you have this, if this is your Earth, then if you have this orbit, what is this orbit? It's the polar orbit, because it's always going to equatorial orbit. Is it going to go to the pole anytime?
No.
It's not going to go to the pole, right? No other orbit other than the polar orbit is going to visit the poles. Make sense? No other orbit other than the polar orbit. So what is the inclination of a polar orbit? Huh? How much? Say that again.
360.
What is the inclination of a polar orbit? It's very simple. If the inclination of an equatorial orbit is zero, what is it? Huh?
90.
90.
But it's going to
It's going to do that, right? You have to be confident and say 90. Shout it.
You guys have no number I was saying. So
Okay? Alright. So you understand why these are something you should develop an intuitive understanding of how to go from an earth frame to an orbit frame. This is required because when something is orbiting, when you're trying to understand orbits, you have to get into that orbit. You have to get into that visualization. So you have to go from earth frame to orbital frame. You understand? Now let's do another exercise.
I have a question.
Yes.
Are these three the same as three at the top, the multiplication sequence?
The multiplication sequence is always reversed. So if I want to convert ECI frame to PQW frame, if I give you this cap omega I small omega, what will you do?
You'd use that up there, but reverse it.
Right. I'll tell you, let me tell you this. Okay? Let me ask you this question. Given now you have learned something, omega I small omega. What is this equal to?
0, 1. No.
Oh, and 3 is split. Why are you taking this away?
Go ahead.
Oh.
I need to get it out. R3 lowercase omega.
Yes.
Oh.
You got it? R3 lowercase omega R 1 I R.
3 capital
And if I write this, I'm going to write what is this in a matrix form? No.
Because it's backwards, so that's cosine
Omega
omega
sine omega 0 minus sine omega cosine omega 0
0.
and then it is 1 0 0 0 0
cosine I sine I
Mm-hmm. And then negative
negative
sign
sine I
and a cosine.
multiplied by
The same thing.
sine. Because y goes back.
It's the same thing as
I
that.
forgot, it's Z. Z. I was thinking
Negative sign,
negative.
cosine.
get it?
Let's do it where y is involved, so I can see that.
So you see what is this? So what you're going to do is, if you have a vector, if you have, let's say the position vector of you're given the position vector of a satellite, you're given R in ECI frame. Okay, and we have done this, right? We are given R in ECI and V in ECI. What is R in PQW and V in PQW? It's the same vector. R PQW, this is a relationship, is equal to you understand? This is going to be a little bit challenging, so pay attention and ask me questions if you have any doubt. Me.
I can't look at it.
Does this make sense? So let me give you this again. Let's analyze this in the just in a 2D context. Okay. So this is your x, y frame. Okay. And you have some vector, let's say vector A, right? And this is your z prime and y prime and x prime. Right? This is also A. A is what? How do you express A in just xy?
R.
So you look at this. This is the x component. Sorry, y component. You write this as ax, sorry, ay, sorry, ax
Cosine.
x plus ay y.
Yeah, okay.
You with me? What is this x? What is this component?
Cosine.
This.
Cosine.
Okay. So this will be a cosine theta. I'm just using ax for a cosine theta. Can I write this? Like this?
Yeah.
I can write it like that, right? Now what is, tell me what is this? R x prime, y prime, z prime, x, y, z.
You gotta go backwards. Right.
So the way we read it is
You go
the
ahead.
rotation matrix associated with going from xyz to x prime, y prime, z prime. What is the rotation matrix associated with going from x prime to xy to x prime, y prime, z prime? Let's say this is z and z prime.
It'll be what we just did, right?
What is it?
Zero.
What is this, guys? We have done this. We have been doing this all the time.
It'll be the 1 0 0 0 cosine theta cosine theta negative sine.
1 0 0 or
It'll be 0
it will be what? Which one of this it will be?
1 1. It'll be the middle one.
This one?
Yeah.
What is rotation about?
Z. So you have the first
It will be this one or
Wait,
this
it's
one.
a rotation of okay, it makes sense.
It's called z, right?
Yes.
Right? Got it? It will be cosine
Oh, what's the
theta
Cosine theta sine
theta 0
negative sine theta cosine theta is
0, 0, 0, 1.
Okay. What is this now? A x y x prime y prime. This same vector expressed in another frame is this cosine theta. So what I do is I write this here. Now just be with me here. Let me go. Let's go. R x prime y prime z prime 2x y z a x y, or cosine theta sin theta 0 minus sin theta cosine theta 0 0 0 1. This is a a1. What is the order of this matrix? What is the resultant of this multiplication? What is the order of the resultant? It will again be a 3 by 1 matrix. Because it's 3 by 3 multiplied by 3 by 1, you're going to get a 3 by 1. This vector will again be a 3 by 1 vector. So you see, this is the same vector A. The vector itself is independent of coordinate system. You understand? Depending on which coordinate system you express it in, what changes? The components change. Can you do this? X double prime y double prime. Can I express this in this vector A in this? You see, the vector is the same. Vector itself is the same. It depends on, this is your perspective. For example, if you're looking at something, some point,
It's just the change in direction of that component.
that component will change. It's like that point will be there itself, depending on whether you use this coordinate system or that coordinate system. It will change. The components will change. How you measure x, y, z will change. You understand? That's what the vector is. That's what we are learning here. Coordinate transformation. So this R, what is this R? Position of the orbiting body. Position vector of the orbiting body. So orbiting body will be there itself, right? At whatever time instance you consider, the orbiting body is that space is fixed. But depending on how you see it, whether you see it from the ECI frame or whether you see it from PQW frame, what will change? The components will change. Got it? Yes. So that component will change. Now you have to understand that component. So this R, how you see R. So when you're doing this PQW frame, what component will you not have here? This R will not have what component? Why so?
Because it's
It won't have W component. It won't have this. It's always in that plane, right? So if you look at this, if you consider any vector in this plane, it will not have this component. Right? So this PQW frame will not always have only P and Q component. P component is this, Q component is this. Will it ever have W component? It will never have W component. Will velocity have W component? Velocity will not have W component either. If velocity has W component, it will change the plane. Because
No W's.
no W's. Okay, but it is not so for x, y, z. This will have all three components. When you are seeing it in ECI, it will have x, y, z component. Okay.